Hello everyone, welcome back to another video. In today's video, I'm going to be talking about quadratics once again. However, this time we're going to be taking on a special case of quadratics. This kind of quadratic is called a difference of squares. So we have our first example question on the board, which is 4x squared minus 9. And what do you notice about this expression? Well, actually, the two terms in this expression are both perfect squares. That means that they have a factor that when multiplied with itself is equal to that number. So the two factors of 4x squared is going to be 2x times itself, and that is according to the exponent rules. When you multiply two powers, then you add their exponents. So with x to the power of 1 times itself, we're going to have x to the power of 1 plus 1, which is equal to x squared. And for our second term, our two factors are going to be 3 times itself. Now, because this is our first example, we're going to use the long method, which is the method we usually use to factor quadratics. The quadratics we usually work with are in the general pattern of ax squared plus bx and plus c. However, it doesn't look like our expression has a middle term. We only have the a term and the c term. So this is how we're going to rewrite our expression to have a middle term. We're going to bring down our first term, 4x squared, and then for our middle term, we're going to plus a 0x. That just cancels it out and doesn't do anything to the expression. And then we have our negative 9, which is our c term. Now let's take our usual approach to factoring quadratics. The leading coefficient on this quadratic is not a 1. That means we're going to have to multiply the coefficient of the first term with the last term. That gives us a negative 36, which means we have to find two special numbers that multiply to negative 36 and add up to 0. Now, because the coefficient of our middle term is a 0, you're going to notice that our two special numbers have to have the same absolute value, meaning they're the same number except one is positive, one is negative. So in our case, 6 times negative 6 is equal to negative 36, and 6 plus negative 6 is equal to 0. Alright, now let's rewrite our expression one more time, but splitting the middle term into 2. So what we're going to write is 4x squared, which is our first term, and then plus a 6x and minus a 6x and minus 9. Okay, you'll notice that the two middle terms in our expression will cancel each other out, and that is why in our original expression we don't have a middle term. So now let's pull the GCF out of each of the two sets of terms. We have a 2x on the outside. Inside the bracket, we have 2x plus 3, and pull out a GCF from our second half, which is negative 3. Inside our bracket, we have 2x and plus 3 once again. So now our final answer is going to consist of two sets of brackets. One of them is 2x minus 3, which is the ones outside of the brackets, and 2x plus 3, which is inside the bracket. Now let's take a look at these two sets of brackets. Their numbers and variables are the exact same. However, in between, the signs are opposites. One is minus and one is plus. Hence the name difference of squares, because when you multiply this out or expand it, you're going to be left with a minus 9. Here we have another example, this time with a middle term. Now let me show you a little trick. Do you notice that the first term and the last term are both perfect squares? The squared factor of 9m squared being 3m, and the squared factor of 16 being 4. So when this occurs, when our first term and our last term are both perfect squares, we know that our special two numbers that we need to find are both the same number. So let me prove that to you. We're going to begin by multiplying our first term coefficient with our last term, 9 times 16, which is 144. So our two special numbers have to multiply to 144 and add up to our middle term coefficient, 24. And actually, those two special numbers are both the number 12. So 12 times 12 is equal to 144, and 12 plus 12 is equal to 24. So now let's rewrite our expression with our middle term split into two parts. It's going to be 9m squared plus 12m plus 12m again, and plus our last term, 16. Now let's factor out a GCF from both halves of our expression, and we're going to notice that in our answer, there's going to be two brackets that consist of the exact same contents. So our final answer is going to be 3m plus 4 inside a bracket and squared. And there we go. That is a little look on special cases of factoring quadratics. Thank you so much for watching, and I'll see you next time.